we are so excited to solve some rational equations. We have some nice ones for you guys to solve. So I hope you're ready to start solving rational equations, which, like I said in the Prezi video, mostly what we've been dealing with so far are rational expressions, which those are things that do not have an equal sign. But these, if you notice, have these awesome equal signs in them. Okay, so some of the things we do in these problems you can only do if you have an equal sign. Okay, some of the things I tell you to do, you're going to want to try to do them when you don't have an equal sign, but that's when the demon cats are coming for you. You have to be careful. These have equal signs, so they are different than when we solve without equal signs, so be careful. All right, so let's get going. So our first step says to factor only our denominators. So let's take a look here at this first example. Okay, I'm going to make sure all of these have denominators since we're talking about the denominators, which my 2, a denominator is not listed, but 2 is secretly over a 1. So that's like 2 over 1. So the first step is to factor our denominators, which since I only have monomials, you can't really factor monomials, so we're done with that step. We can't factor, so we're good to go. The next step is to find the LCM, which stands for least common multiple. We want to find the smallest thing that all of my denominators can multiply to equal, which actually, this is the same process we use as when we find a common denominator. But I do not want to call it a common denominator because our goal with rational equations is to actually make the fractions disappear. Okay, so we're going to be math magicians and we're not going to have fractions, which makes our life much easier when we're solving. So I don't want to call it a common denominator because we're not trying to keep our denominators. We're trying to annihilate our denominators. We're trying to get rid of them. Okay, so this time we're going to call it the LCM, but it is the same process we use to find the common denominator. And like when we find the common denominator afterwards, we're going to find where it's undefined by setting each factor not equal to 0. So kind of act like you're finding a common denominator, but we're just going to call it the LCM, or least common multiple. So let's find that thing. All right, so our LCM, remember, I want to grab one of every different kind of thing that I see in the denominator to form my LCM. So I have a 1. I don't see any other 1s, so I need to include it. I have an X, but I don't see any other X's, so I'm just going to write X. And I have a 3, but again, I don't see any other 3s, so I'm just going to write a 3. So my LCM is going to end up equaling 3X. Okay, so that's the first step, and now I need to find where this thing is undefined because when we solve equations, you guys, we're actually going to get answers for our x's, and we need to make sure that our denominators never go to 0. Okay, our kitten dies, and we're not trying to do that. We love kittens, see? We love them, yay! They're cute and cuddly and furry and make cute little noises, so we love them. Okay, so we want to make sure our denominator never goes 0. So first and foremost, we got to set our LCM. We set all of our factors not equal to 0, so we don't kill any kittens. So let's find where this thing is undefined. That's the next step. Okay, so my LCM is 3x, so I'm going to set 3x not equal to 0. And let's solve this thing. So in order to bring positive 3 to the other side, or in order to bring my 3 to the other side, it's secretly multiplying to my x, so I'm going to divide it on both sides. Which 3 divided by 3 cancels out and turns to 1, and 0 divided by 3 is 0. So x cannot be 0. Okay, so we need to keep that in the back of our mind because if I get an answer of 0, it's not allowed. And we're going to call it extraneous. So be on the lookout for that. Okay, so those first 2 steps are donezo. Bam and bam. Next step, it says to multiply each term by the LCM. Okay, so this is actually easier than when we were adding and subtracting fractions because I don't even have to think about like what does this denominator need that it still needs from the LCM or my common denominator. Okay, you are going to literally take this LCM and multiply it to every single numerator you see. And when we do that, our fractions should disappear. So let's see what happens. Okay, so I'm going to write what I have up here, and I'm going to leave some space in between so I have room to multiply the LCM to each term. So I'm going to have 2 over 1 plus 4 over x equals 10 over 3. Alrighty, so I'm going to take the LCM and I'm going to multiply it to every single numerator I see. Remember, we are not trying to get common denominators. Now, it's not wrong if you get a common denominator, but it's going to take a lot more time and a lot more work to solve. This is a much shorter way. And in math, we're all about efficiency. So let's be efficient students and do the fast way. Okay, so my LCM is 3x, so I'm going to multiply that bad boy to every single numerator. All of them. Okay, and what we're looking for is to cancel out our denominators, because if my LCM contains things from each of my numerators, they should just go away. Now be careful, you guys. We can only do this when we have an equal sign. You cannot cross out fractions when you don't have an equal sign. The reason why, say that I had the number, I don't know, let's say I had the number, 4 over 7. Okay, without an equal sign. I don't have an equal sign right now. Okay, if I just decide, first of all, when you have something that's not an equal sign, you can't just multiply some random number to it. Like if I just multiplied like a 7 to this, that's going to change the value of my fraction now. Okay, so first of all, you can't even do it because it changes the value of what you started with. And secondly, again, if I multiply it by 7 and make my fraction disappear, I now have a 4, and 4 is not equal to 4 over 7. Okay, so you cannot do this when there's not an equal sign. There's a ton of illegal moves going on right here. Now, the reason why we can do this with an equal sign is because when you have an equation, you keep the equation balanced if you do something on both sides. So we're not changing the value of anything because an equation is all about keeping things balanced. So since I multiplied it to every single term, it's kind of like I didn't really multiply it at all because I did it to all my terms, so they're going to stay balanced. Okay, which if that didn't make sense, you guys, you just have to remember you can only do this if there's an equal sign. Without the equal sign, it does not work. Okay, so all that addition and subtraction we did, you cannot do this in that section unless there's an equal sign. So be careful. Okay, so let's see. Our fraction should be disappearing. So let's see here. Which this one, you guys, wasn't even really a fraction to begin with. So I don't even really have to care about this 1 because anything over 1 is itself. So this is just like 2 times 3x. So I'm just going to bring this down. My 1, secretly there's a 1 multiplying it. So my 1's are going to cancel out. Okay, so I'm left with 2 times 3x. Okay, now my next one, again, my goal is to make the fraction or my denominators disappear. There's my disappear fingers. Okay, so I see an x and an x, so they're going to cancel out. So all I'm left with is the 4 and the 3. And then this will equal, let's see what's going to cancel out here. Holy hot dog, do you guys see the 3's? The 3's will cancel. So I'm left with 10 times x. Holy hot dog, do you guys see we just eliminated our fractions? No more fractions. Pretty exciting, right? So now I just need to multiply and simplify. Guys, so if you think you can take it from here, because now we're just solving just an equation, go ahead and pause the video and fast forward to the end. But don't forget, our x's can't be 0. So if you get 0, remember it's called extraneous. All right, guys, let's solve this thing. So 2 times 3x gives me 6x. 4 times 3 gives me 12, and 10 times x gives me 10x. Okay, I want to try to combine my x's together, so I'm going to bring my 6x to the other side. The way I bring a positive 6x to the other side is by subtracting it, doing the opposite. Which 6x minus 6x cancels out and turns to 0, and 10x minus 6x is 4x. So this is 12 equals 4x. Alright, and the way we bring 4 to the other side, it secretly is multiplying to my x, so I'm going to divide both sides by 4. Which 4 divided by 4 cancels out and turns to 1, and 12 divided by 4 is 3. So this is going to be x equals 3. Now, technically, before we just go ahead and box it, we need to look back to our undefined. The values that will make our denominator 0 are 0. which I didn't get 0, thankfully. I got 3. So this answer is good to go. Yay, it worked. So in this one, x is equal to 3. Wasn't that awesome, you guys? We made our fractions disappear, and we were able to easily solve for x. Fun times.